In this video, we are going to create the rendering system for our game.
That's right. We're going to be taking a method that we've already kind of used a couple of times now, once with the sound engine and again with the screen system, where we're going to create a base abstract class from which we will later descend the actual renderers that we'll be using.
Exactly. One thing to point out is that we want to create the renderer architecture in such a way that renderers can be swapped out easily, even during gameplay.
Now, why do we want multiple renderers?
Primarily for debugging and for the renderer development.
Okay.
To show that the data architecture and the visual architecture are modular inside of the game itself. What I mean by that is you can have a song represented vertically or horizontally, and it doesn't matter to the song. We just have a setup to where the renderer can take the sound data and apply that in a visual manner.
All right.
So
basically, we're just modularizing the whole system.
Exactly. So what we're going to be doing in this video is making the base renderer class. That class is going to have both instance and static elements. The instance methods are going to form a basic interface, which all renderers will share, and the static elements are going to manage all of the renderers currently in existence. So let's get started with the renderer class. We'll jump up here to our core folder inside of the project and add a new class. This class is going to be called renderer. So with the class dropped in, we'll pull out the sub namespace of .core, and we will mark the renderer class as being abstract. Because once again, we're going to be in a scenario where you would never want to instantiate the base renderer class because it doesn't do anything. Now let's jump in and handle the instance side of things. As a matter of fact, before we jump into these methods, we are going to be creating some drawing functionality that's going to utilize the sprite batch type. So let's actually drop in some using statements. We're going to grab using statements for XNA.framework and graphics, and we can probably steal those from the screen game class. So once again, we're getting XNA.framework and framework.graphics. Now with these methods, or rather these types available to us, let's define two methods. First and most importantly is the draw method, since that is going to be the purpose of any given renderer, is to draw song information to the screen. So we're going to make a public method. We're going to, in this case, mark the method as abstract, which will require that the method be implemented in whatever class descends from renderer.
Okay.
In this case, we're not leaving the draw method as optional, since to not override draw would mean you shouldn't even be using a renderer.
Right, because there's nothing, you don't have any drawing code actually taking place.
Exactly. We will also mark the return type here as void, so we're not going to return anything from the draw method. So we'll drop in the method name as draw, and then we'll take in a few parameters. First of which is going to be the sprite batch to use when drawing. So we'll have a sprite batch parameter called sprite batch. And we will also have a song parameter, since again the idea of the renderer is that it's not in charge of rendering the entire screen, it's in charge of rendering a specific song. So everything done inside of the renderer is going to be targeted at song data.
Where everything else is actually managed in the screens themselves, isn't it?
That's right, there's already draw functionality in any given screen, so any element that's going to appear once in a screen will be handled in the screen's own draw method.
Okay.
So we will pass the song into the renderer in order for it to be rendered. So we'll pass in a song parameter. And since this method is abstract, we don't have to worry about a method body, and we'll simply terminate this statement. Alright, moving on, we have one other method to address. Now internally, the renderer is going to use a positioning system, where it has a set of rules that define where any given note will be placed. And this note placement rule set is useful to some classes, some external classes. When we get into the rendering system, or excuse me, the editor system, the editor is going to need to know whether or not a given note is currently on screen. And in order to do that, it will have to ask the rendering system, since really it's the song renderer that's in charge of where notes go. So we need to have a way that we can ask the renderer where things will be positioned. So we're going to make a method called getStaffPosition. So we'll have a public method, we'll make it virtual, and we'll have a vector2 as the return type. Again, the method name is getStaffPosition. The reason for the name staff is since the renderer is targeted at rendering a song, this is to make it kind of correlate to sheet music, where the main thing that you're drawing when you're writing notes on sheet music is the musical staff. So the idea is that really the renderer's job is to turn song data into a staff. Now getStaffPosition is going to be created in such a way that we feed in tick and track information for a specific song, and then the method will kick back exactly where that note should be placed. Because again, really a note's placement is dependent on two pieces of data, a tick, or a location in time, and a track, or a location in the horizontal sense, vertically. So we'll take an integer for tick, and an integer for track. And finally, we need to take in the song instance itself, just in case there is anything about the song, any further property or parameter we're taking into account. So we'll make a song parameter called song. Now we can drop in the method body, since we need to return something to satisfy our vector2 return type. And in the base implementation, all we're going to return is vector2.0. Because any given renderer may be placing notes differently in different positions on the screen, so it will be up to the specific renderer to override getStaffPosition with an implementation that makes sense.
Okay. So 0 will just be our default value.
Alright, before we move on, let's mark this whole section as our instance methods, just to make it a little bit easier to tell this section apart from our static renderer management. As a matter of fact, let's drop that into a comment as well. We've got renderer management. Now, what we're going to do inside of renderer management is keep a list of renderers, all the renderers that currently exist. That will allow us to create more than one, and will also give a facility for switching between them. Now, in order to mark which renderer is currently active, we're going to make a field called renderer index. So we'll have a static integer called renderer index. That way we can select renderers by picking an index that matches one of the renderers in the renderers list. Now we need to create the list to store renderers. So we'll make a public list. So we have public static list of type renderer, and we will call this list renderers. And we will instantiate the list using a field initializer. Alright, now that we've got the renderers list, just to make it a little bit more convenient to access the active renderer, we'll put the renderer's lookup into a property. That makes it a little bit more obvious as to what should be used when grabbing a specific renderer. So we'll make a public static property called active renderer. We'll define the type of this property to be renderer. So we have static renderer active renderer. Now inside of this property we'll make a read-only property, so we'll drop in a get accessor, and inside of that accessor we will return the current renderer by looking into the renderers list and returning element sub render index. Then we can close off the brace to end our get accessor, and one final brace to end our property. Alright, one last thing we need to do with the renderer management, and that is to specify a way that we can change what the current renderer is, because currently this index variable that points at a specific renderer is private. We can't get to it from the outside world. So we're going to make a public method, public static void change renderer. Now we're not going to give ourselves the ability to walk forwards and backwards. We're going to create a simple method that is going to cycle through each renderer, and when it gets to the end of the list, automatically wrap back around to the beginning.
Mm-hmm.
So in order to do that, we're going to be modifying the renderer index variable. So we'll say that renderer index is equal to plus plus renderer index. So that means we advance the actual variable first, or excuse me, we advance the value in the field first before storing it. And the reason that we're advancing it before we evaluate the statement is so that we can, inline, do a check and modulus the result against the total number of renderers. Meaning, if we had called change renderer and we were already looking at the last renderer in the list, the first thing we would do would be to advance the index so that it's actually past the end of the list. Then we could modulus that result against the total number of renderers, looking in renderers.count, and then that would wrap us back around to 0. So that means the full result of the expression would be to store 0 in renderer index.
Sure. So no matter how many renders you'd have, you just dance all the way down through the list. When you got to the bottom, you jump back up to the top.
Exactly. And with that, that's all the code we need to put into the base renderer class. So I'll make sure that this gets saved out. And now let's take a look at making an actual renderer, because of course we need to descend from renderer to give ourselves a class that we can instantiate. So let's jump in here to the game folder and add a new item. This item is going to be called render horizontal. So we'll drop this class in place. We will remove our sub namespace, and we'll drop in the same using statements that are in the base renderer. So we'll gain access to the types from framework and framework.graphics. Now we need to also make sure that renderer horizontal extends renderer. Then inside of our brand new renderer, we can turn around and immediately override the draw method. And to save a little bit of time on getting a base example implementation for draw, we could go over to our screen game class where we currently have some temporary rendering code. So what I'm going to do is start up here at the center variable and copy everything down right before BPM text. We'll cut all of this code and we'll move it into the renderer horizontal.
Well, it makes sense. All this stuff does is just kind of control how those notes were coming across our screen, and we don't really want the screen to manage that anymore.
Exactly. That's what we're working towards, is more modularity. So we're pulling musical rendering code out of the screen and shifting that over to a specific renderer, and then later in time those renderers could be more easily cycled through. And I've also noticed a slight bit of spelling error in our definition. Looking in renderer, we've got the sprite batch with not entirely the correct name. We'll hit F2 so we can refactor this. So we'll rename this from this to sprite batch. And then we'll grab that name and make sure that it also gets applied over here in our override in the renderer horizontal class. And then that should take care of that spelling. Now we've got the renderer set up, but we need to make sure that the renderer is accessible inside of the renderer's management code. So we can use things like renderer.activeRenderer. To do that, we need to make sure that this renderer class, this renderer horizontal, gets instantiated and gets put into the renderer's list. We'll do that inside of the game class. So we'll scroll all the way down in our Solution Explorer and bring up game 1. And inside of game 1, we'll look for the load content method. Inside of load content, we'll jump in just before we create all of our screens. We'll make a section called renderers. And then all we'll do in here is make sure that we instantiate a new instance of renderer horizontal. But then we need to turn around and store this instance into the renderers list. So we'll look into the renderer class, find our renderers list, and add this new instance into that list. because now we have that first element in the list. Our renderer index will start at 0, and that means renderer.activeRenderer will now be pointing at this instance of renderer horizontal.
Right, and therein lies your flexibility to add in multiple renderers, because you just add them onto this list, just increment them over and over again.
Exactly. In much the same manner as we were adding screens to the screen management system. Now, there's one last thing we need to do before we can test the scenario out. At the moment, we're never calling our renderer's draw method. As a matter of fact, we should be able to play the game now, and we should be hearing notes playing in the background, but we wouldn't see anything. So let's test this theory. If we load up the game now and jump into game, we do indeed have sound, but we're not seeing anything. And the reason is, over here in the game screen, we removed all of the note rendering code, and now nothing is calling the new renderer.
Right, we got to talk to the rendering system we just built.
Now, this is interesting, where we're going to be calling the renderer's draw method from inside of a given screen, in this case inside of the game screen. The reason we're doing this is to give ourselves the flexibility to place the renderer draw call between our background drawing and anything we may want to draw over a renderer. For example, some HUD-style text, where we have our BPM readouts.
Or maybe later on your own, if you wanted to do, like, some sort of really cool, wow, you just hit 150% or something, you could do that on top.
Right, you could draw an effect over the entire thing.
Yeah.
So here inside of the screen, or the game screen, we're going to look at the renderer class. We're going to pick the active renderer out of that class, and we will tell it to draw. Now we need to pass along a sprite batch, which we already have from our own call to draw, and a song to draw. And we have that stored inside of the game screen as the song field. So we'll simply pass that along. So now instead of having all of the bulky note rendering code present in the game screen, we just say, oh, we have this song, and we would like it to be drawn. And we pass all of that responsibility onto the renderer. So let's run the game and see how things are looking. Here we have our notes back.
And everything is working.
So while we're getting the same visual result, we've given ourselves much more flexibility in how we go about drawing our note information.
Very cool.
So with that, that's going to wrap up this lesson.